continue on our discussion and stay on this subject with a panel on digital twins, the developer's fast lane, moderated by Cheryl Ajlouni, Keysight's Director of Industry Solutions.
Despite 2.5 years of uncertainty, many of us entered 2022 with cautious optimism. But as we look at technologies like digital twins and artificial intelligence, it's clear the recent advances have been anything but cautious. While the rest of the world paused or was forced to pivot to address the uncertainty, these technologies continue to take bold steps forward, advancing at lightning speed, and that path of progress shows no signs of slowing anytime soon. Hi, my name is Cheryl Ajlouni, and I'm the Director of Industry Solutions at Keysight Technologies. Joining me today is a panel of experts who will be talking to us about digital twins and artificial intelligence and how these revolutionary technologies are and will impact the very complex world of product development. Our panel includes Dr. Poppy Crum, an expert in tech-driven innovation and human evolution, and adjunct professor at Stanford University. Jonathan Wright, Chief Technology Evangelist for Keysight Eggplant Software. Dr. Arnal Dayaratna, Research Vice President in Software Development at the market research firm IDC, and Armando Valum, Director of Software Products at Keysight Technologies. Welcome to all of you. So to kick off this discussion, I'd like to start with asking you all a question to kind of make sure we're all on the same page. And I'm going to throw the question to you, Poppy. And I'd really like to know what your definition of a digital twin is.
Digital twin. All right. So I think everyone here believes that and knows that a digital twin is not a new thing. They've been around for a long time. It's really about how do we take the physical environment and digitize that in a way that we can interact with it, that we can gain information and insight about that physical environment. Now, a few things that are important when we think about a digital twin. Any digital twin is really multiple time series of data. It's contextually dynamic. It's something that we are gathering, we're gathering information about the physics. It can be in many different areas. So many different dimensions, and how effectively we featurize that data and how the resolution and frequency of how we capture it is what's so important to its effectiveness. Let me give a simple example I like to use. Air traffic controllers, they've been using digitizations of their environment and the physical environment that they're in, that they're interacting with, are critical to how effective they've been for many years. And what's really interesting when you think about that is a digital twin's role is to always make humans have better insight, whether it's giving insight to an autonomous system or insight to the individual themselves. For the air traffic controller, if we look at history, it's the visualization of that information to help their neural system be more effective with that data. What's changed is now even in that data, that digital twin, it's changed in how resource allocation and considerations for path planning of those aircraft, not just safety. It changes the dimensions of how someone can interact with those physical objects. So we go from physical, we digitize that environment, we create effective ways of transforming that data through what I like to call situational awareness, from the perception of that data. And this is all how we gather that data, from sensing to the way that we comprehend it and have insight, to drive feedback loops of intelligence that let us alter and interact with that digital system, all under the guise of enabling situational intelligence for us. Great. Situational intelligence, situational awareness, terms used in the military a lot, but they have application to every domain that we intersect. And our digital twin is effectively always about how do we improve our situational intelligence in whatever domain or whatever aspect we're trying to interact with in our work life or our home life, frankly.
Wonderful. That's a really nice definition to get us started here. And Jonathan, I see you nodding along. Did you want to add something to that?
Yeah, absolutely. That was an amazing, great example. And it actually brings me back to a practical example where I was helping with the optimizing with the UK radar airports, where they were looking at creating digital twins to optimize for reducing carbon footprint. Okay. And so part of it was when there's obviously Heathrow, very busy airport, how do we create a 3D model so that we can optimize and reduce potentially that environmental impact. And that's that situational awareness of, well, what are we trying to do? We're taking huge, and I'm going to use the word exhaust data for a second, but part of taking that huge amount of data and then actually be able to create a model out of it, run those simulations, and then optimize those flight paths. So actually, once we're able to share data, we're able to build on these digital twins, there's all types of new opportunities for us to build on. And of course, when it comes to aircraft and autonomous aircraft, we've had some great examples where the autonomous system had a bit of a problem, and there was unfortunately a bit of a crash where the autopilot wasn't able to disengage because the sensors were telling two different things. And I think this really talks about why it's so important to be able to simulate and emulate these really complex systems and make sure that they are not only for safety reasons, but also understand how these systems work together.
Sure.
And I think that brings Keysight really into, well, you need to understand the whole ecosystem of that digital twin.
Right. And you mentioned Keysight, so I'm going to now throw the question to you, Armando, and ask you, how does Keysight define a digital twin?
I'll throw a very simple definition on the table. That's the one I think about it. A digital twin is a good known source, a good known signal. For the double A's in the audience, it is a good known source or sink. But to help me illustrate a little bit the idea of digital twins in Keysight, I would like to talk about a very common, very simple children's toy. It's called the tin can telephone. So for a second, let's create a digital twin of the tin can telephone. We'll go to the right side and we'll digitally replicate tin can telephone. We'll try to replicate its attributes, its behaviors, like Poppy mentioned a second ago. For the tin can telephone, if it's acting like a receiver, everything is a transmitter. If it's acting like a transmitter, everything is a receiver. Everything that our customers do in PathWave design is a digital twin functionality. They are constantly creating, modeling, simulating, using known good signals, known good sources to model their designs. The other side, the physical side, can we use digital twins to simulate the physical side of the tin can telephone? And the answer is yes. But we need another ingredient. We need digital and analog hardware plus software. As Poppy said, the software is digital twin software. And then we have emulators. And as we all know, we really need emulators to test. They're critical to testing products. They can replicate devices, buses, communications. They can even replicate a 5G or 6G cell phone call. Now, I know my definitions are a little simple, but there is some elegance and maybe some math and some measures that you have to make so these digital twins have a high fidelity. And without that, we cannot really use them in the real world.
Great. And can you just take a second to tell us how you're defining an emulator, because there might be some people in the audience who don't actually know what that is.
In the physical world, at times you need to test a device and you need to replicate the functionality of that device.
Okay.
So emulators are hardware plus software products that emulate those devices. I'm going a little round. I'm going to use an example, a radar. We just released last December a radar simulator.
Right.
And what it does is, for automotive, it helps you simulate hundreds of objects without you having to put the car on the street and drive on the street.
Right.
So you can use this radar emulator to replicate the world around you without having to drive the car.
Great. I appreciate that clarification. Thanks so much. So Arnal, I'm going to throw the next question your way. And I wanted to know, why are digital twins essential to accelerate development? So can you give us some insight into that?
That's a great question, Cheryl. And this technology is essential to the acceleration of development, in my view, for at least two reasons. The first of which is its enablement of the enhancement of testing. And this happens through a multitude of modalities, such as the rapid expansion of the universe of test cases, to enhanced A/B and multivariate testing, which is a methodology that has been around for decades, but it undergoes or experiences a quantum leap in the advancement of its sophistication, courtesy of this technology. And then in addition, I would say there's a certain kind of acceleration of test execution, as well as enhanced developer agility with respect to test execution. And then the second reason has to do more with enhanced product development capabilities and augmented capabilities to understand the behavior of objects in different circumstances and environments, as well as the performance of objects given minute or perhaps not so minute changes to their structure and composition.
Right.
And with respect to product development, another important contribution of digital twins to development is their ability to facilitate deepened insight into the relationships between attributes of a product.
Mm-hmm.
And so this is important for product design and product development in ways that I think are qualitatively different from testing. Both of these things, namely advancements in testing and product development, enable improved quality as well as cost savings and enhanced innovation. And I think all of those topics are topics we'll touch on later.
Excellent. Thank you so much for that response. And I think, Poppy, you feel strongly about this topic. Is there something you wanted to add to that?
The thing I would say is, like from a testing perspective, the advances we have in a digital twin today, one, in emulators to be able to truly model behaviors of hardware components and interactions of the environment, sensors in the environment. You're changing the insights that people can have in ways that completely alter product development as well as testing. And two examples I like to think about are we have very different ways we're gathering the data today. Changes in frequency, changes in resolution of that data, changes in what that data is. On the if I'm in the constructible environment, right, from a built to a BEM to an as-built, I would have an environment where the digitization of that data would exist. I would have my physical model that I'm building to that would be static effectively. It would go to bed and then we'd look at where all the mistakes we made later and have to go and rework them. And 40% of construction is rework, fixing mistakes, carbon that doesn't need to go into the environment. And instead today, we are completely changing how we can interact in the environment, the frequency of how we're understanding that relationship in our situational intelligence and the mapping between that physical and environment. And that transforms, to Jonathan's point, we can think about resource efficiency very differently. Mm-hmm. We can interact with a physical system in a way that allows us to completely alter how we are, even the ideas we would have on its scalability for how we control our systems and provide, benefits. And then, to top it off, if you think about where that data is coming from, if you walk into the medical environment and you think about, where we're going with digital twins in product development, thinking about where that data, where the time series are come from, and the insights that we can gather. We even have the idea that we now track our microbiome. We track our neural insights, continuously. We are tracking, biometric data or behavioral data. You suddenly have a lot of data. The effectiveness comes from how we weight those time series in digital twins to make us effective. And Jonathan, I know, is going to rock and tell us all about that.
Well, one of the things we want to talk about is use cases. So can you respond and sort of give us an example of some use cases or couch it in that?
Yeah, and I'm going to kind of set it up for some quite exciting stuff that we're going to be talking about later on. But that wonderful example. So actually, I was in Australia working for a smart health campus where they were actually using mixed reality and VR to allow them to understand where the best positioning for medical equipment was. So they're starting about smart building, all these kind of sensor data that you could potentially be capturing before it's actually built. And I think this is really interesting because when we go into things like Car2X with the great example earlier on, Infrastructure 2X, part of it is we're building these new cities, but we've not got the data because we've not built the city yet. So Springfield, which is is a smart city in Australia, they are taking data from other smart city projects around the world, Cambridge, Dubai, and then then using that as an experiment, i.e. a simulation, to be able to then say to themselves, how do we build this for the future? And I think that's the great thing about what we're talking about today, is that this autonomous design aspect of being able to get better at the design also then bridges over to the cyber-physical, to the actual, how do we improve once those systems exist? What kind of data do we need to be taking? How do we understand that patients are getting the care they want? You know, their emotional states, whether or not the queues are too long, all this kind of information, video analytics, SLAM for predictive maintenance, all of this is based on understanding and the creation of these digital twins. So they're absolutely critical on how we evolve as humans to actually be able to build smarter, more, environmental, sustainable, responsible solutions.
And that's a great example, because there's academic data, there's use case assessments of digital twins in like a wing of a hospital. Time saved, overtime, number of hours of overtime per day saved by an effective digital twin. Optimization of where you place things so that people navigate effectively. That's a beautiful closed loop system where you can really make people more effective. It leads to life saves. It leads to less stress. I mean, it's like you start objectifying what it means to improving human life, insight, or even the uses of physical devices in those spaces. It's really powerful.
So it sounds like digital twins really is a very much a transformative technology. That's the way you're describing it, at least, yeah. So that was great hearing about some of the applications or use cases of digital twins today. But I think I'd like to take us a little bit deeper diving into looking at what are the actual advantages and benefits of using a digital twin. And I think, Armando, I'm going to send that question your way. Could you start us off and give us some details on that?
Yes, I love the cities and the hospital. It touched all of us. But I'd like to bring a little bit closer to the product development we all suffer. And understand first the problems. There is products are getting complex. We have shortened development cycle. That leads to what Poppy said earlier, this digital transformation. We need more things digitized. And I'll give you one example. A PA, that's a power amplifier, used very commonly on all cell phones. Used to be a very simple device. And now those PAs have over 1,500 modes. All those need to be simulated and need to be tested. Before, those were literally dumb devices. So how do we use these digital twins? How can we talk about it in a way that we make this product development better? I'll use an old framework. I give you that. I'd like to bring the V product development cycle. And what is the V for the ones that are not as familiar? The V goes through all the steps from concept to prototype, and then from prototype to product. It really maps what a product development cycle is. Also gives an idea of time, where those phases should be. The first benefit, visible benefit on this diagram that digital twins bring is we can, on the left side of the V, connect all those phases. The earlier we start with digitization, with a model, all the design cycle can be compressed. On the right side, the physical side of the V, as we talked, emulators can help connect. If you have an emulator that goes from prototype all the way to production, you can help compress and connect all the phases on the right side of the V. Well, but that's not exactly what we want. Then I think the next benefit is we can use the digital twins to move from the left side of the V to the right side of the V. And we also can use the data from the emulators to give information to the models so they're more correct, literally closing the V. We talked about two benefits. I'll give you one more. Automation. We are now digitizing all this information. We have this connection between the design and the models to the real world. Automation is really important. It helps save time, helps make things faster. We have a recent survey from Forrester. They talked to test leaders, and only 1 in 10 companies fully automates tests. That's not where we want to be. The question then was asked, what about the next 3 years? Over half of those would like to automate in the next 3 years. So automation is an important missing key on us using more digital twins. And the fourth benefit of digital twins is with more data, more connection, more automation, we can finally use advanced analytics, artificial intelligence, machine learning, things that are far from our normal product development process right now. But they can bring a lot of intelligence, save a lot of time, and make products much better, in my opinion.
So do digital twins and artificial intelligence work together, or is one an enabler of the other? How would you define that?
In my view, in my humble view, we can use both tools. Those are tools in the toolbox. Digital twins modeling. You can use artificial intelligence to make those digital twins better. Digital twins and automation. You can use automation to make the digital twins get more information and be better on test. Digital twins, machine learning, get all this data and really progress digital twins. To me, those are all tools in the same toolbox for developers. But I would like to hear from the rest of the crew.
Yeah, and it would be interesting to get a different perspective because he's brought up this idea of the V model, which is a very engineering specific term, and it's been around a while, right? But there are other people in the audience who might want a broader perspective. So do you want to add something, Jonathan?
Yeah, I will do, because I think it's time to go back to kind of Keysight's heritage, right?
Okay.
So if you go, yesterday I was at the Dave at Hewlett-Packard's garage, right? So back in 1938, they were building the first test equipment, and they were using evolutional design. They were building and testing quite rapidly, building out, in essence, something that's never been done before, and they were learning from it. Now, the first learning examples, when they first sold the first unit to Disney in 1939 for Fantasia, straight away they got product feedback as part of that life cycle that said, actually, it was okay, the product, but we'd love it to be able to just do this. So the quick feedback loop to give them in this case, the 200B, which was a much more successful product, which is exactly what Disney wanted. It's starting to see that evolution design of getting very rapid feedback. But I think more importantly, there's so many different points to test that product through its life cycle. And there's a focus on shifting earlier in the life cycle to test as much as we possibly can. But I think where we're moving to is actually how do we shift that right to then learn about what's happening in the real world and all that, what the customer, the usage, all that additional information so that we can optimize and improve our products continuously. They evolve. It's evolution and not revolution. It's not just a big bang of a new product. It's how do we improve on what we're doing. And I think this is the journey that they started off at Hewlett-Packard and we are on today. But I think it's the shift of saying, we don't have to test everything so early. We need to start learning from other types of simulation and emulation in the real world.
Did you want to add something to that, Poppy?
Three things that I think come out of effective digital twins are personalization, customization, and fundamentally risk mitigation, whether it's for the customer, the B2B customer, or to the consumer, of how they interact with their products. And from a perspective, I love examples where two things I want to say. When you asked a question of how machine learning and digital twins work, you can have a static digital twin, digitization of the physical world. What's changed and is so different is how we now can assess and collect different dimensions of data, either about components in the emulator of that digital twin, their behaviors through their life cycles, interacting with the environment, interacting with other components in that environment. And it's not just a digitization of them. It's really becomes now we get to become more insightful and through the software, through the featurizations and the dimensionality reductions that we look at in this dynamic, complex system. And it doesn't just get higher resolution frequency, it changes the questions that we ask. It changes how we think about scalability. There's an example I like of a manufacturing plant that has been used, and I love this where it was a T-shirt manufacturing plant that was partnered with another large company in their digital twin software, and what they realized is there was a lot of product that was showing up damaged, and they were able to track down from one position, geographic position with plants all over the world, exactly which manufacturing line was causing that, because it was a slight shift in temperature data happening on one conveyor belt that was causing, the shirts that came off of that to mold. And you would historically have to pull all of your, if you think about the risk mitigation that comes with that kind of insight, and it completely changes the problems you think about, how connected you are as, in solving them. Armando, why don't you go
I have
on?
an example. We have a product called Keysight Manufacturing Analytics.
There, perfect.
And it's collecting, exactly what you're saying, collecting data. This is automotive manufacturer, collecting the data, and the original data was pass-fail. But the software has artificial intelligence. So it started looking at the data and told the engineers, guys, there is not only pass-fail, there's pass-fails, and these are the two groups. So now the engineers can use that knowledge that came from artificial intelligence, from getting all this data from the digital twin, and understand, so what's going on, and solve the problem, save millions of dollars.
It changes the business model fundamentally when I have different trust in my data. And I think that's a really important thing.
Yeah, really great points. Arnold, did you want to add anything to this conversation as well?
So it seems to me there's an improvement in quality that manufacturers can expect to experience because of the reduction in defects, but not only because of the reduction in defects, but also because of the accelerated resolution of any defects that arise, right? I think there's also an enhancement of customer experience, or user experience, I should say, because of a more frequent cadence of innovation and richer innovation more generally, which may be enabled by artificial intelligence and data-driven analytics more generally, I would say. Obviously, there are cost savings because of this more intelligent approach to product development that reduces operational costs associated with testing, that provides enhanced insight about the behavior of products in relation to changes in their environment, changes into their internal and external environment. And additionally, or finally, what I would say is the benefit of acceleration, right? Of accelerated developer velocity and the ability to rapidly work through minor modifications to software.
So one of the things I've heard, I think all of you talk about at some point during this conversation so far, is fidelity. And I'd like to dig into that a little bit more and kind of understand what you mean by that, and what you think the impact is for digital twins. So Jonathan, can we start with you and dig in?
Yeah, sure. And I'm going to go back to the history a little bit.
Okay.
Just again, because I was in Santa Rosa, our headquarters, and originally Hewlett and Packard picked that location because they wanted to control the manufacturing process, right? Which our CEO, Satish, his office directly below is the manufacturing production line. And of course, there's a huge amount of precision in what we do, but also there's a whole stack of calibration of what good looks like. And I think you mentioned the word around quality, and of course, quality is incredibly subjective. But we were able to understand through standards and certification that it's within a certain tolerance, especially with hardware, but we don't really have that with software. And I think it's really interesting because we're learning from the manufacturing processes, which are very established, which were the examples we've already given. But how do we do this when we apply software? Now we know all these devices have software on them, embedded with them. It's the infinite complexity. And we know these devices are starting to be connected, so they can pull that information. And actually, when I did the manufacturing tour yesterday, they said they had the similar kind of problem when they started shipping certain components to Penang. Just the environmental changes and how there was certain things in the air particles caused them to see the calibration change just through transportation, even though they put all the kind of the guards in place. The point is we're learning from these discrete things, which are anomalies, and they're the kind of, you're detecting them, and you can use things like machine learning to start taking that huge amount of data of how people are using the devices, how they're testing devices, to learn more about it and to inform us and do more with less, be very efficient of what we're doing. And I think that's really what type of data are we trying to capture and what are we going to do with that data, which is then going to add value to how our products are going to evolve over time. And so even our own, drinking our own champagne, going through that kind of process, we're learning of how we improve that continuously and evolve. And I think that's really critical to think about how you do that, how customers are thinking about how they use the product, how they test the product throughout the life cycle, and what data they should be capturing at what resolution.
Poppy, did you want to talk about fidelity at all? Did you have anything you wanted to add?
That was a great answer because it hit on so many parts of what's changed. Which, circling back, digital twins aren't new. The way we can depend on them, use them in our product development, use them in our quality, everything we think about with regard to even how we assess our risk mitigation in a business decisions can be gained from an effective digital twin. And we are, I think, an important aspect for me, at least in looking at a lot of the areas I intersect, which have been, from the built environment all the way to right now, thinking about a lot about how we learn about our bodies in our spaces and optimize human performance, is, it's that frequency of data, the fidelity of data, but then the effectiveness of the digital twin isn't just having that data. We have new dimensions that a digital twin has many time series, and it's the effectiveness of how those time series are used to gain insights through machine learning and AI to gain effective, directed action, actions to that system. And that is something that I think has just massively expanded in the last few years.
Can I throw a case study?
Sure.
User example?
Of course.
There is a company called Mainlo Micro. They were developing a high-power radio frequency switch, fancy words, literally an on-off switch for RF signals. And the problem they had was they wanted to simulate, create a digital twin to simulate the little die. This is semiconductor, very small thing, before it's ever produced. And then they had a different problem. They added to it, well, customers cannot use the die, they need the package. So they needed to simulate the die inside the package. Well, turns out customers also don't use the package. They use the package, the component on the PCB. So they concluded that for them to be successful with their digital twin, they had to start with understanding, validate the die, the package, and validate the component on the PCB. They had to use 3D electromagnetic design environment to simulate all that. I'm talking about voodoo magic for the ones that don't understand what I'm talking about here. But they could, on design, do all those simulations, those measurements. And I'll talk about fidelity now. They were able to get, when they all done, save 65% on development cycle. And they were able to measure 1 dB, the correlation very close between the simulated data and the measurement data, and just have 1 dB of difference on a frequency range all the way to 12 gigahertz to 15 gigahertz, talking about frequency. This is very impressive. But going to the point of these digital twins, they have to be high fidelity because companies cannot count on them. They cannot spend all this money creating a component if the results are not close to reality.
Really interesting conversation. I appreciate you giving us that ad. And I love the way, Jonathan, you keep taking us back to the history with Hewlett and Packard. But I'd like to push us ahead into the future a little bit. And Arnaud, one of the questions I'd like to ask of you is, if we look 3 to 5 years in the future, what do you see as sort of the growth opportunities, development areas for digital twins? Can you give us some insight into that?
Sure. So I'll touch on one in particular, and that is the deepened integration of artificial intelligence and machine learning into digital twin technology. And this is something that has happened already, but it will be certainly amplified in the next 3 to 5 years. And the examples that come to mind relate to optimization and personalization, and they're two different examples. So the example of optimization involves something that Poppy alluded to proleptically, and that's the scenario of a pharmaceutical manufacturer who's manufacturing a drug in 3 different continents, let's just say hypothetically in the United States, in Italy, and in Japan. And they've noticed that despite the fact that each of the manufacturing plants in each 3 countries leverages and works on and implements the same manufacturing protocols and steps, there are significant differences in the cost and quality of the end product that is produced between these 3 sites. And so the challenge for this manufacturer was to understand what the root cause here is. And this is a problem that is not reducible to a testing problem because the manufacturer doesn't know what the issue is. And they had to leverage machine learning to understand how very minute variations in the implementation of different manufacturing steps had enormous repercussions for cost and quality. And this relates to a parallel conversation about personalization and, in the world of e-commerce, for example, and this is something we've been doing for at least a decade. There's interest, obviously, in understanding how the position and shape and color and morphology of a shopping cart influences conversions. But one thing that digital twin technology enables is more nuanced analysis of the relationship between all of those attributes of the shopping cart and conversions as segmented by different demographic groups and purchasing patterns. So, for example, men between the ages of 20 and 29 who spend X% of their income on tech, for example. So one trend that I envision is deepened use of artificial intelligence and machine learning to enable more advanced optimization analytics as well as more advanced personalization analytics.
Great. And did anyone else want to add? Poppy?
Yeah, no, to that on personalization analytics and optimization analytics, those are really at the core of everything. But what, next 3 to 5 years, if there's one thing I truly hope is, and I see happening is, digital twin, like this community thinks about digital twins. I can walk to a lot of communities that should be thinking about digital twins. It's completely relevant to their success, or even consumers that are, what they need is a digital twin and they don't know it. And they think about the digital twin as something in the metaverse or something that's, in fact, it's the success of their life, if they get it right. And so where I think it's just a really important thing to think about, okay, so the role of what a digital twin will have different meaning to everyone. It allows technology to become more empathetic to us. And where I like, technology, we trust it differently, that we believe in the intent it is serving for us, whether we're a business, whether we're an individual. Examples I give is, aging in place, where, you have elders now able to live in their home autonomously and not have to go into care facilities because of the digital twin that their caregiver, their family has of their environment through their sensors, through knowing the information about them. It's only through that we have trust that they're okay. And it also gives us different insight that we can engage with them differently. You've got companies that are building effectively, dynamic office spaces that use the data of the environment. They have effective digital twins of all of the HVAC systems and things, allow them to have a very dynamic system. But then they also have information about the individuals in that space and how they use that space and how their bodies react to that space that can dynamically change that building in a way that makes them more effective. Suddenly, it's changing our relationship with technology, where I like to think of it as an extension of our technology becomes a much more trusted extension of ourselves, that it comes with a cost. It means more data is being used about us in our environments, which is a whole other panel, but it is changing. It's not just something that sits in a definition of what it is. It becomes something that we have to think about, well, where do these digital twins matter? Is it how I optimize my home, my family, what I eat to make me more effective? Because I've got all that data now too, right?
So just to add on to that, I think it's a wonderful example, and I love the fact that you've highlighted the word trust. So one of the use cases for Eggplant, which is one of the Keysight family products, which uses artificial intelligence and digital twins, we were working with MIT during the pandemic for their exposure notifications to run simulations of how people used it. Now, it was designed to be for less developed countries, 47 different languages, different age groups. And of course, having the app, which straight away is asking, initially, can we track you? Can we have access to your personal data? Part of you've got to put the trust into the product that it's going to be able to take that information and do something. And of course, there's different contact tracing solutions that came out. A lot of them was under criticism about privacy challenges. And what we did within Eggplant is we created 2 billion historical representations of people moving around. In this case, it was Boston. And then we started then simulating the Bluetooth proximity when people were interacting with each other, and the trust was that you didn't get false positives. So in actual fact, the Eggplant helped them generate, I think, over 10,000 different permutations of different interactions with different sensors and different devices. We're able to prove that without them actually having to leave the lab, with all those environmental components to it. And I think that's the whole point, is we need to be able to trust, but we also need to, we need to know that the data that's being created is accurate, and we're not going to get these false positives, and also with the damage to our brand if we're not able to successfully deploy this and also save lives in that particular context.
Yeah, trust, save lives, and people gained capability. I mean, they gained different types because of that what you built in that situation.
Fascinating. And I think we're actually coming to the close. So I've got one last question I'm going to ask you all. Really, just very quickly, what is the greatest thing that you think digital twins can do in the future? And maybe we can just kind of go down the line. I'll start with you, Jonathan.
Sure. So I'm here in Santa Clara talking to some of the big organizations doing the next generation of virtual reality, mixed reality headsets that are using eye tracking, the change towards the metaverse. And Satish actually presented this a keynote he did quite recently. Being able to test the metaverse of that blurring the boundaries between technology and the real world, how we interface with technology, how we're moving away from maybe a mobile device into something where we're able to interact with people. We're able to, especially during after the pandemic, co-create and work in different areas in distributed remote location. So being able to test those, but the examples we've got, and going back to kind of the factory example, that we've got these environmental chambers where we're able to simulate the twilight. That there's a certain amount of light coming through. You're in the desert. There's a certain temperature there. You're able to test those devices, see if they can augment onto it. The 6-directional robots are able to show how the sensors and the movement are happening, the body tracking, the eye tracking, all coming together to show what is that experience? Because fooling your brain, if anyone's used VR recently, it's moving that forward so that we can actually help utilize this technology to collaborate across the entire planet. We've got to also test that. We're going to test the edge of the meta, how people interact, how the technology works, how the network digital twins, the last mile. This is in our heritage, and we're ready to start testing the next generation of devices in the metaverse.
Poppy, how about you?
Digital twins are about giving humans more insight, making us more effective, and efficient, but also making us more efficient in how we use our planet. So for me, the most important thing that we can tackle right now, where digital twins have such an important impact, is on sustainability, and not just the decisions we make going forward, the decisions we make to fix the mistakes we made in the past. An example I really love is how, I don't love when we make mistakes in our planet, but where we built dams throughout our countries, throughout California. We instituted we developed dams that in fact broke down ecosystems. We've been able to model those and effectively restore ecosystems, return nature to what it should be, and help it flourish, help species that were becoming endangered or not behaving, not migrating in the ways that they should, start to be return to their natural setting because of digital twins. And I love when technology and data and insight help us bring the world back to the natural world that we should have. And then we get to flourish as humans without, with technology around us, but in the background supporting us.
Nice, nice. Arnold, how about you?
My sense is there's tremendous opportunity for digital twin technology to deliver significant enhancements in medicine and cancer treatment. So, for example, what would it mean if we had more advanced insight or knowledge of the consequence of the removal of an organ, let's say, or a tumor within a body that was deemed to be cancerous, as opposed to waiting for the introduction of some kind of treatment, let's say chemotherapy or immunotherapy or some kind of pharmacological treatment. And so it seems to me decisions are often made to remove an organ based on gut. And I think there's an opportunity to use a data-driven approach to obtain a more nuanced understanding of how disease can spread throughout a body and what are the potential scenarios and to model those.
Armando, how about you?
I'd like to pick maybe a different approach to answer. We talked about the company's benefits, we talked about the world benefits, we talked about saving lives. Maybe I'll break the third wall here. And I think this digital twins, automation, artificial intelligence will have impact on our lives, we as product developers. As I mentioned, a survey from Forrester, only 1 in 10 companies automate, but most of them see the need to automate. Only 16% of companies, organizations use artificial intelligence now, but 52% expect to use artificial intelligence the next 3 years. So I think that this is a revolution, it's a transformation, and it will in fact affect our jobs.
Excellent. I appreciate all of your answers, and I am so sad to say that this is the end of our time together. It's been a great conversation, such an amazing group of people that are amassed here to talk about this really important subject. And again, I just want to thank all of you for participating in the panel. I want to thank everyone in our audience for being here with us today. Hopefully you've enjoyed our discussion and were able to get some answers to many of the burning questions you may have had around digital twins and artificial intelligence. Hopefully you at least know what a digital twin is, if nothing else. So thank you again for attending this panel, and I hope you have a great day.